Welcome, my dear learners, to today's episode on this very channel. Without wasting much time, we have a question on the board. Let's look at how best we can approach question of this very form. We have log of x to the base of 2 plus log of x to the base of 3, and this is equal to 5. We want to find the value for x that satisfies this logarithmic equation. Looking at these two logarithmic expressions, the bases are not the same. We have a base of 2, we have a base of 3, and therefore we can't apply the laws of logarithm to work it at this very point. So what we are going to do is to send this log of x to the base of 3 to the right hand side of the equation. So we shall have So looking at the right hand side, we have log of x to the base of 3. Now let's express 5 in a logarithm form with a base of 3. In logarithm, we said that when you have the logarithm of a number, let's say a, to the base of the same number gives us 1. Therefore, if you have log of the number 3 to the base of 3, this will give us what? 1. So when we multiply it by 5, this will be the same as that. So in place of this 5, we are going to substitute the whole of this. And we have done nothing to this number 5. So we are going to have from this low point, we can apply the power law for logarithm. So this 5 will move to this very part. So at the end, we are going to have 3 raised to the power 5 to the base of 3 minus what? Log of x to the base of 3. And we know that 3 raised to the power 5 will give us what? 243. So we are going to have log of 243 to the base of 3 minus what? Log of x to the base of 3. Now we have log to the base of 3, log to the base of 3, they are subtracting. Therefore, we can apply the division law for logarithm. We are going to pick one of the logs to the base of 3. So we have log to the base of 3. And then what do? We divide the numbers. 243 all over what? X. We are having log of x to the base of 2 is equal to the whole of this. Now continuing at this very point becomes very tough. So let's equate the whole of this to any variable at all. Let's say the variable y. So from here we can say that log of x to the base of 2 is equal to y, or log of 3 to the base of this number is equal to y. So let's continue from this side. Log of x to the base of 2 is equal to what? Y. And log to the base of 3 is also equal to y. Now once you have this, we can convert this into an exponential equation. So the base of this logarithm will become the base of this y. So at the end, we are going to have 2 raised to the power y is equal to x. We are also going to convert this into an exponential equation where the base of the logarithm will become the base of the y. So we are going to have 3 raised to the power y is equal to 243 all over x. Now we have two systems of equation. Let's call this equation 1 and then this equation 2. Now let's multiply equation 1 by equation 2. So we have 2 raised to the power y, multiplying the dot the same as multiplication. 3 raised to the power y is equal to x multiplying what? 243 all over x. From these points, we can see that x can cancel x. In indices, we said that when you have a multiplying another number, let's say b to the power of m, we can write it as a raised to the power m multiplying b raised to the power m. If that is the case, we can write 2 raised to the power y multiplying 3 raised to the power y as 2 multiplying 3, and then we pick one of the exponents, which is y. So we have 2 times 3 give us what? 6 raised to the power y is equal to 2y multiplying 3 raised to the power y. So therefore, in place of this, we are going to substitute 6 raised to the power y. We have 243. Let's convert this into an exponential form. So in doing that, we are going to have 243 is equal to 6 raised to the power y. So we are going to introduce logarithm on the left hand side, and then the base of the y will move and become the base of the logarithm. So we are going to have log of 243 to the base 6 is equal to y. So we have y is equal to log of 243 to the base of 6. So within the question, we don't have the variable y. We introduced the variable y, and we said that we are letting y is equal to this logarithm, or we are letting y is equal to this. So let's pick this one, which says that y is equal to log of x to the base of 2. We also have another y, which is saying that log of 243 to the base of x. By transitivity law, we can say that this log is equal to this logarithm. So we shall have log of 243 to the base of 6 is equal to log of x to the base of 2. Now our interest is to find the value for x. Now that we have x here, let's convert the whole of this into an exponential equation. So the base of this logarithm will move and become the base of this whole expression. So we are going to have 2 raised to the power log of 243 to the base of 6 is equal to x. So this is the value for x that satisfies this logarithmic equation. Better still, we can convert this into a decimal fraction, and we are going to have our x to be equal to 8.3729497, as easy as ABCD. This brings us to the end of today's lesson. See you tomorrow. Bye bye.